Okay, so now it should be about to start recording any second. There we go. Still got to post a whole bunch of videos. All right. So we dealt with this equation more with what we were doing before when we did linear equations. So basically equations that we could graph into a line. That was when we said, okay, I know this is the y-intercept. So I put a point on the y-axis. From there, I then do the rise over the run, which is what slope, the formula for slope. So I go over the right, and then I go up and down to get my second point. We did that a lot more. We did do this method, and we did it actually quite a bit as well, not nearly as much as that one. We said in this problem, I'm going to get rid of this graphing thing. You do need graph paper, especially next class, Kylie. That was just more my reminder to let you know that. Oh, I don't need that too. So we said, if we have an equation like that, y is not all by itself. We can't do the rise, run, slope, all that stuff. There's another method, and we're basically we're trying to find an x and a y value that make that equation true. And the way we're going to do that is to make our math as easy as possible. So the easiest math is zeros. So we said we're going to plug in 0 for x. And when we do that, 2 times 0 is just going to become 0 and just kind of go away. And then we'll do the same thing for y and we'll solve out. I'm going to skip straight to the cheat sheet method that we learned. And no, I can't believe nobody remembered this method. We did the one called cover up and solve. Cover up and solve means you just cover one up. Act like it's not there. Cover it up. Put your thumb on it. Put your pencil on it. Depends on how small you write, I guess. Or how big your thumbs are. Now I just solve for y. You're always going to do the same thing when you do this method, at least on stuff I make up. You can divide by whatever numbers with the variable. So y is still y. I'm sorry, the 5 goes away, the y is still there. 100 divided by 5 is 20. So I got y equals 20. I'll tell you what we do with that in a second. Now I'm going to do the same thing. What was it, 2x? 2x plus 5y equals 100. So now I cover up this one. Well, I always divide by whatever number is there. X equals 50.
And then you graph those.
Well, and you graph them in a specific way. This is actually 2 different points on the graph because we need 2 points to make a graph. So and I'm only going to make the positive part of a graph. Technically, you'd have, the lines would cross and there'd be other quadrants. But we don't have any negative numbers, so I don't really need to worry about all the other areas. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So those are going by tens, because I don't want to try to write from 1 to 50 on a graph. So 10, 20, 30, 40, 50, 10, 20, 30, 40, 50. So y equals 20. This is my y-axis. So y equals 20 would go right there. X equals 50, 10, 20, 30, 40, 50. That's how you graph that one. Cover one up, solve for the variable. Cover the other one up, solve for that variable. Then you should have 2 points on the graph after that. One where the x number is on the x-axis, one where the y number is on the y-axis.
So I always thought I had to have 2 points.
What's that?
I thought I always had to have 2 points.
No, a line is just 2 points. Once you have 2 points, you just connect those 2 points and there's a line. You can't do it with 1 point. You got to have 2, but you don't need 3. I mean, you could test a third one just to make sure you didn't make a mistake on the first 2. Because theoretically, if I did the math wrong on one of these, and let's say I accidentally put the point up there and graphed this line, well, that's wrong. So if I tested a third point, the third point, if I did it right, would be way down here, and I'd be like, oh, wait a minute, That can't be right then if I did that line way up there. So a third point would tell you for sure that you did the first two correctly, but you don't need a third point as long as you do them correctly. So we're going to be doing a lot. We're going to be doing word problems for a while. And with word problems, and we're going to be doing what's called a system of equations like we did in the last class, the video and everything, system of equations. Those problems just tend to have equations that are more like this than y equals mx plus b type equations. Although in the video, those equations were actually y equals mx plus b. So you will see some of those. Any questions? So here's the deal. I got really mad at my last class. I feel bad now. Because it wasn't their fault. It was my fault. Because they weren't getting it. Like, I mean, not getting it. Like, I went through the whole lesson, gave them, every time I gave them something to do, nobody did anything. They weren't getting it. Although a lot of them don't try to get it. I can't help you if you're not telling me you're not getting something. Like, every time I would finish something, any questions, nobody would say a peep, not a word. If you're not getting something, you need to tell me you're not getting it. Ask me a question. Say, whoa, how'd you get that? That's all you gotta do. How'd you get that? Trust me, you are not the only one that's not getting it. Like I said, the entire last class didn't get this whole lesson. Nothing. Like literally nothing on this whole lesson. I had a couple people that did, but the vast majority of the class, almost everyone, did not get it. So if you're not getting it, speak up. Even if you are getting it, but you're maybe a little confused, just speak up if you're willing to speak up. Because a lot of people aren't. All right, anyway. We did this problem. Yeah, well, not yesterday, last class. I'm going to give you the quick review. Was anybody not here last class? All right, so here's your like super fast review.
Oh, wasn't it? Oh, I think I was here.
Oh wait, real quick. Here's Nelly. I gotta tell you this.
It's that
first.
one where you tried to.
Yeah, I gotta tell you this first. So you have a big quiz coming up and a big exit ticket next week. What I'm doing is I'm putting together a packet of word problems. These are all the possible word problems I could put on the quiz. I'm not making any new word problems. We can't even give this stuff out. This has medication in it. So we can't. Technically, cough drops have medication. I am not making up any new, I shouldn't say, the wording could be slightly different. Like it might be a different type of story, but it'll be the same type of process to solve it. Some of them will be the exact same wording. I might put the exact same wording on there. And we're going to work some of them out in class. So as long as you worked them out, all you got to do is change the number, then you put the new numbers in and boom, you're done. Some of them I won't touch, but again, there'll be possible questions I could ask on the quiz, because I'm not pulling anything from anywhere else. Every single question will be in this packet. Oh, I'm going to put this on focus. I'm not going to print it up. There's going to be quite a few pages. I want to kill a bunch of trees, and a lot of you will never use it, so I'm not going to print it up for people that aren't going to use it. If for some reason you try to look at it or you try to download or something happens and you truly want to get a printed copy, then you can come to me later and I'll probably print up a copy for you.
People want it and then like write it down and then print it.
What?
You like ask people what the actual copy.
Well, I'm going to put it on focus first and we'll take it from there because again I print so much. You see that stack of papers that we never use. Yeah. I mean, I'm starting to kill forests, not even trees anymore. So, and again, that doesn't even count everything I gave away that kids didn't use. So when I put this together, if you really care about your grade, because you're going to have 2 big grades coming up, the exit ticket for you guys will be on Thursday. Wait, is that right? I see you Tuesday. Yeah. So you only have 1 more day after today. So your first exit ticket will be Thursday. It'll probably have also some other stuff on it. Like it's not just going to be on the word problems I give you. You'll probably have some stuff from the old stuff we just did, the arithmetic sequence stuff. But the word problems tend to be the hardest stuff, so that's why I'm putting the packet together. So you basically have all the test questions ahead of time. They won't all be worked out. You have to put some work in, but if you're willing to put the work in, you should have no problem with a word problem. All right, so anyway, on this one, we said an equation is a rule. I can create from that rule the equation. In this problem, we said the rule is he's got to spend $15. First part of that is maybe writing it in words. So the money spent on airheads plus the money spent on, I'm just going to write HB for honey buns. So however much he spends on airheads plus however much he spends on honey buns has got to equal $15. I'm going to go ahead and stop you right now before the next thing I give you. That's an equation. Well, it's sort of an equation. We're going to make it into a real equation. Solving it is figure out how many honey buns he bought and how many airheads he bought. Too many people, when I tell them to write an equation, they solve. You're not solving anything in what I'm going to ask you to do next. You're just writing the equation. So don't try to figure out how many he bought. That's not writing an equation. It'll never be writing an equation. If you're figuring out the answer, you're not writing an equation. They're two totally separate things. So I said the way I would create this, the money spent on airheads, if you haven't been with me for a while, well, even if you have, I'll repeat it. Most of the time, when you're trying to put this into an equation, it's how much is one of them times how many. Well, how much is one airhead? Well, $1. How many airheads? Well, it says right in the problem, X is the number of airheads. So how much is 1 times how many? All right, well, same thing for honey buns. How much is 1? $2. How many of them? Well, Y was the number of honey buns, so how many is Y? And then that's going to equal the total amount of money, which we already said was 15. That is the one and only equation for the cost, for the money part of this. It doesn't change. I got people trying to say, oh, well, it's 7x plus 4y. No, you're solving. The 7 and the 4 are the answer. The equation is that. That's it for the money part of it. So make sure when you're creating an equation, you're not trying to figure out what the answer is. You're trying to figure out what information is in the word problem and how do I translate that information into an equation. And that's what we're basically doing all day today. Now next I came in and I said I created a second rule. So that's a rule. The money spent on airheads plus the money spent on honey buns has to equal $15. I also gave you a second rule. Second rule was this. Actually, I don't know what it was in this class. I'm going to use this one. He bought 11 total items. That was the second rule. So again, I've got to figure out how do I make that into a rule or into an equation. If it's the rule, I gotta make it into an equation. Well, the total items is just made up of how many of one plus how many of the other one. And I already know that the how many, the number of airheads is X, the number of honey buns is Y. So we said the second equation was just the number of airheads plus the number of honey buns has to equal 11. If you can figure out how to say it in words, the words tell you exactly what your equation is. The number of airheads plus the number of honey buns is equals, and I'm going to write a whole bunch of those in a minute, 11. 11 total items.
Wait, weren't we supposed to do like 13?
That's about the money though. So you can do the two things. This is about money. That's why I put dollar signs in. The money has to equal 15. The total number of items.
Oh, items is
is 11. So there's always going to be two rules. So you don't get the two rules mixed up.
Okay.
Combined. Two separate rules.
So the rule is on the bottom and the cost is on the top.
No, they're both rules. They're two rules. You have to spend $15. That's one rule. You have to walk out with 11 items. That's two rules. But one's about money, one's about the number of items.
So you just like give us another one?
What's that?
You just give us
Yeah, no, I saw that one because we had already done it. I'm going to give you another one to do on your own, trust me, like right now. So absorb that. Yeah, here's the point where if you don't get something I just did, you need to be telling me you don't get it. Because I can't help you if you're not asking me, okay, wait, Ms. Gill, how did you get that part of it? And trust me, you're not, I guarantee you people aren't getting it. They're just not willing to speak up. So hopefully I just need one person that's not getting a piece of it to ask for everybody else that's not getting it. Because I know other people aren't getting it. Nobody wants to say anything about anything they're not getting. What you got?
So
Thank
you're
you.
just covering up the X and solving for Y?
We're not solving anything.
So like,
Don't even worry about solving it. We are creating, literally, your standard, your topic we're on, is creating equations. Creating, didn't say solving, creating the equation from a word problem. We'll get to solving. Right now, don't worry about the answer. You have to be able to translate words into equations. Then you solve the equations to get the answer. That's the last step. We got to figure out how to create the equations first. No bathroom if that's what. Okay.
What does it mean by let x equal the number?
It just means assign the variable x to be equal to that. And that's a great question because you need to define your variable first. If I don't tell you what the variable equals, you need to set what the variable equals. So in this one I told you, it says x equals the number of, or how many, either way, same thing. It equals how many airheads, or the number of airheads. Y would be the number of, or how many honey buns. So the first thing you need to do in your problem, always, is define what the variables are. What does X stand for? What does Y stand for? Not solve, just what do they stand for in words? What do they stand for? I told you in this, but if you need to rewrite it in easier to understand words, it's a lot of times going to be either the number of, or how many, or it might be the price of one. In this case, we already knew the cost part, so how many was what we don't know. Oh, and the variable is always what you don't know. If you know it in the problem, then the variable doesn't stand for that. Like we know how much one is, so the variable can't stand for how much it costs. We don't know how many of them we bought, so that's what the variables are going to stand for. It's the unknown part of the problem, always. Normally it comes from somewhere in the question. Like my question was, what are possible combinations? Like how many airheads and how many honey buns did he buy? So that means that's what the variables are. They're the how many airheads and how many honey buns. So if you look at the question, typically that tells you what your variables stand for. You might have to figure it out a little bit, but it'll still give you the information that you would need. All right, so write the equations. Yep, write the equations for that problem. One of the equations I hope is easy. First, define your variables. Remember, you got to say x equals, and then in words, explain what x is going to stand for. Y equals, and then in words, explain what y is going to stand for. And then you can move forward to find, okay, what is the rule I have to follow? The rule is then going to become the equation. And there's two rules in this. Two rules that you have to, two requirements, two rules, whatever you want to call it, that you're going to have to meet. I'll give you like a minute and I'll walk around and see how we're doing. And then I'll probably wait a minute and walk around again. I might give a hint after I walk around the first time. Again, without many questions, I'm expecting you to know how to do this. Because I got a couple questions, which is good, because last class I asked 0 and I walked around and 0 people knew what to do. Well, 1 knew it. So when the red hand gets on the 12, I'll kind of come and just do a first check. I might give some hints when I'm walking around, depending on what you got. I should not see a blank paper though. I can't correct a blank paper. If you write something wrong, I can explain what's not right about it and then what you might be able to do to fix it. You got a blank paper, I can't do anything with that. Make mistakes. Did I tell you my new favorite quote in this class? I think I did, right? Yep. That's my new favorite quote. You learn way more from trying something and not succeeding at it than you ever do when you do something that you already know how to do. All right. Oh, actually, hey, man, you're not solving it. You're not solving it. Create an equation. So where are your equations in it? You don't have a problem. You do have it on the other day, probably. There you go. That's one of them.
She came up with that one too.
Yes, that is correct.
Can you come check me?
Well, I'm not sure what you're doing with that. Oh, I do know what you're doing with that. So you do need those two numbers in it. So again, you need to look back. We did this problem yesterday. Look back at your notes on the problem yesterday. No, because you're saying, remember, we'll define your variables before I say anything. Define your variables.
We mean 0 and minus.
Let me see. No, you're solving it. Nope. Can't go yet. You got to create an equation. Don't try to solve it. Don't figure out what are the numbers, what are the answers. Don't figure that out. You're just looking at the rule. What is the rule? If nothing else, define what the two rules are. Just pick the words out of it and tell you the two rules. You can't do anything else. Yeah, that's what I want you to do. A lot of people aren't. So this is about what? The 1 and the 2 are about what?
How much you spend?
Is the 7 about how much you spend? Then they wouldn't all go in the same equation. So what number is about how much you spend?
Oh, this right here. I got it.
There, but there's another rule. There's another rule you have to follow besides that rule. Again, you're trying to solve it. Equations need to have variables. You need to have variables in an equation. You don't have any variables. Yes, and yes, good. Much more than the last class already. Now you're trying to use everything in one equation. There's two different rules to it. So you'll have two different equations that might help you. That's one of them. Good. That's the one I thought was easy. So that, I don't know if I said this because I do the same thing class after class. The bad thing about word problems is, yeah, they can get a little confused. Good thing about word problems is it's easy for me to get partial credit. Like for example, in this, there's two equations. You get one of the equations, which again, I think one of them is pretty easy. You got 50% on that problem. And if you get 50% on all the hard problems, you'll be fine on a quiz. Again, now this is right, because you have variables in that. There's not any variables in that. There needs to be variables in this. So this is one rule about the money. There's another rule that's not about money. You need to figure out what that rule is and then write the equation. Yeah, same thing. That's about money. Define what X and Y are. Okay, yeah. Now again, you're kind of combining the two rules, or to do much better results in this class for sure. So that's one rule. What's the second rule? One rule is about money. What's the second rule? So that would be one. But no, we don't need to solve anything. Like you don't need to do the one and the one and all that and solve. Oh, well, if you graph it, that's good. So yeah, we could graph that line, but you need the second rule that we would also graph. So one rule, and the funny thing is, you guys are getting the rule that I actually think is the harder rule. Almost everybody got the one that I thought was harder, not the easier one. So one rule is about this. He spends $10. So we would create an equation that uses the dollar amounts. So this is a dollar amount that's going to be in there. That's a dollar amount that's going to be in there. You need to define X and Y though. A lot of you are not doing that piece. What is X going to stand for? Tell me what you want X to stand for.
Airheads.
So remember, number of airheads. You got to be very specific. Because airheads could be the cost of an airhead, which we know, so that can't be the variable.
What, one airhead?
Well, again, the variable is going to be almost always one of two things. How much is one of them, or how many of them? Well, we know how much one is, so that can't be the variable. The variable is the unknown. We don't know how many. So X is the number of, or how many, airheads. So therefore, Y would have to be the number of honey buns. Same thing as the other problem. All right.
Wait, what does the hashtag?
Number
Oh.
means number of. Hashtag, that's so funny. I would have never, ever in a million years thought, oh, I'm putting a hashtag up. Here's why I think these are much easier to solve. Put that in the backpack, please. Phone. Whoever's phone that is. Is that your phone? Oh yeah, if you want to charge it, that's fine, but it needs to be away from you. Because I already see you turn around to check it.
I'll make sure.
Well, unfortunately, that's checking. I didn't say you were texting, I said you're checking. So, all you have to do when you create equations that are like this ax plus by thing, you put the numbers and variables together that are about the same thing. What number is about airheads? Just airheads. 1, right? So 1 goes with X. What number is about honey buns? Just honey buns. 2. So 2 goes with Y. The number and the variable will match up as far as being about the same item, the same thing. Always, like always, they'll match up. And then typically at the end, there's going to be like one larger number, one grand total, as long as we're doing addition at least, which we are in this one. So that's one equation, because that was one rule. He spends $10. But what's the other rule? Did you figure it out, you guys? What's the other rule?
The amount of items.
Yeah, the number of items. This is the second rule that a lot of you didn't necessarily see. He buys a total of 7 things. That's a rule. He walks out of there, not only is he going to have spent $10, but he's going to have 7 things that he walks out with. That's your second rule. So again, that rule is the 7 things is made up of what?
Honey bun.
So say it. What do you mean honey buns?
We have to get 7 items.
How many? What represents how many honey buns?
Why?
Y, right? All right. Well then, how many honey? I'm going to put it on the right. Doesn't really matter where. What represents? So the number of honey buns plus what?
Airhead.
The number of what represents the number of airheads?
Why? I mean,
Oh,
X.
That's your other equation. 2 of you got both of them.
I
Almost all of you got at least one of them, which is, like I said, pretty solid compared to.
No, that's me.
That's left. I hate beating them up. Man, I don't know what was going on. I'm starting to worry that maybe I'd missed something because fourth period, I don't have a second period today. 4th period did okay, but I only had 5 people in there. It's my mostly online class. So I'm glad you guys were getting it at least. So same lesson they got. Hopefully I told them they need to go back and watch this. They also only got half the lesson. So. But again, you've only gotten half the lesson too. All right, so that is the 2, or those are, that is a system of equations right there. That's a definition of a system of equations. We have one problem, and there'll be one solution, but we have 2 rules we have to meet, 2 equations. One rule is about how much he spends. One rule is about how many things he buys. That's a system of equations. And because we have 2 equations and 2 variables, we can solve that. If we had 2 equations I'm sorry, if we had two variables in one equation, we wouldn't be able to solve it. We could graph it, which we're actually going to do now. I was going to make you guys do graphing today, but we're going to do that next week on the Tuesday. So because I'm breaking up the big quiz into two separate, one big exit ticket and then one big quiz. So if I cover this up, I need to divide by 2, right? Because I want to solve for y. So I cover this up. 2 divided by 2 cancels out. 10 divided by 2, I get y equals 5. So 5 goes right there on the y-axis. Now, if I cover this up, well, I'm sorry, if I cover this up, x just equals 10. There's nothing else for me to do. So I'm just graphing the line in red. X just equals 10. Because if I cover up the y term, I just have x equals 10 left. We'd get rid of the 2. Once we solve for y, we don't need all that other stuff anymore. There. So now if I cover up that 2y, I just see x equals 10, so that means x equals 10. So that's one line. I can graph that line. Oh, I got a little off too. So there's one of the lines. Next line, same thing. I'll do this one in green. If I cover up the y term, just x equals 7. All right, well, then I put a dot on x equals 7. If I cover up the x term, well, now it's just y equals 7. I'll put a dot on y equals 7. Now I go ahead and I connect those two. Some of you are trying to solve it instead of creating the equation. Remember, that's two different things. Solving it and figuring out how many he actually bought is not what we're doing. Not right now. I just asked you to create equation. But you did come up with that solution. Most of you are trying it. 4 and 3. So he bought 4 airheads, because X is airheads. And 3 honey buns. Remember, when we watch the video, the point where the 2 lines cross is your solution. So if we graph those 2 out, we see, yep, worked out perfectly. That's the solution. Remember, this is recorded too. And it will always be the solution. Now, sometimes the problem is the lines may cross like here, in the middle of squares or something. I don't know what numbers those are. Like that 7.2 maybe, 7.3, 6.5, 6.4. I don't know what those numbers are. So we're going to learn 2 other ways to actually solve out and come up with a number mathematically, algebraically. For right now, though, we're going to just graph, and the lines will typically cross right at integers, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, just like here is 4 and 3. Any questions on that? You guys did pretty well on that. Now, it was the same exact problem that we just did the numbers, which the last class did. You can do well on that one. God, I keep beating the last one. And we're going to watch this video. Sorry, guys. I love you. But you do need to watch this video again. So.
Okay. Wait, the same one?
Yeah. Well, they're already watching it. Good point.
Wait, like.
Yes, now you can go back. There is another one I'm going to put up, so hurry back because I want you to still try it.
Hello.
All right, so here's your order of things. Write this down. Step 1, even if it's done for you, it's not a bad idea. Define the variables. Define the variables. So even if it's already kind of in the problem, it still doesn't hurt to write x equals this. And you can normally shorten it up a little bit and make it easier for you to understand. Number 2. Now you want to say, all right, what are my 2 rules in the word problem? You're looking for the rules. And then now there's not always 2. So when I say 2, it's because of the topic we're in. Before there was just 1 rule in everything we did before. So, but now we're dealing with a system of equations. So there's 2 rules. And then, and this is a pretty big jump from 2 to 3, but you want to change each rule into an equation. You're not solving anything. That's a totally separate step, which is the last thing we do. So that's the very generic process. I'll give you a second to write that down, and then I'm going to give you one to try that's not similar to what we just did, so it'll be a little tougher. There's one of the rules, though, is still pretty easy. So in the next problem I give you, and I don't tell you what the variables stand for. You need to define the variable. What does x stands for, or x equals, but in word, not a number, you're not solving for it. You're just saying, well, x is going to stand for what? Like in this case, it was the number of areas. And then y stands for what? Then find what the rules are in the words. Which part of that is the rules? You can underline it, you can write them, both the rules out separately in Word. Kind of like I wrote, the money spent on airheads plus the money spent on honey buns equals $15. That was a rule. And then lastly, now you got to try to change those rules into 2 equations. Converting the words. Oh, yeah, we'll get to this in a second. I'm not going to write it right now. All right, so here's your problem to try on your own. Pinellas Park played Clearwater High in soccer. Oh, cough drop. Pinellas Park played Clearwater High in soccer. Pinellas Park won by 5 goals. The total number of goals in the game was 9. What was the final score? I don't know. Pre-K, I hope you can do it.
Wait, how much?
Oh,
yeah, it's pre-K. What is each one?
So first, you need to define your variables. That's the first step. X is going to stand for this. Or X is going to equal this. Y is going to equal that. That will be one of them. Yep. That's the easy one.
That's what I just
I
asked.
told you. Wait, what?
How much the goals are worth?
Oh, in soccer, everything's worth 1.
Okay, okay.
I didn't even think about the fact that people not.
I still have to put my phone in here.
I haven't, but you need to do that quickly is what you need to do. Because you tend to take those extended, you're actually supposed to be on probation. But since you did that equation, I'll let you go. So define what x equals, meaning not x is this number, you're not solving. You're saying x is going to stand for, but basically you write x equals, and then in words what it's going to stand for, like number of airheads in the other problem. And I told you it's very typical for a variable to either be how many of something or how much does one of them cost, or how much is in just one of them. Like if it's cars and buses, how many students in a bus would be maybe what the variable might stand for. So I'll give you a minute and I'll walk around. So I'll give you until the red hand gets to the 12, and I want to see what you got. Please don't have a blank page. You get it wrong, you get it wrong. Like, we can fix a blank page. I'm sorry, we can fix something that's wrong. I can't, if I don't see anything there, I don't know what to do. There's nothing I can do. You got a blank page. Take a guess. You just did some equations in a problem. Look at those equations, see if one of them makes sense. A lot of times they do. You'll notice that sometimes equations are kind of repeated over and over and over again, one particular one. Oh, late. Wait, yeah. Okay, I would say number of goals. Yeah, interesting, perfect. Good. Well, this is correct. So x is, well, no, x is not the total number. But be more specific. You have two missing things. No, because we know they're worth one each. That doesn't really play in this. They're always worth one each. Both teams. So what do we not know? Again, think about what you don't know. What is it you're trying to find out ultimately? And what's that made of? How many goals for? Think of the final score. When you look at that scoreboard, what do you see?
Numbers
Where?
on the board.
Where on the board?
On the board.
Where on the board?
On one of the teams.
Oh, wait, what did you just say?
On the team.
How many?
I didn't say a specific number.
No, not how many goals. How many teams?
2.
So you got goals for,
20.
which is who? Pick one.
No.
And then goals for?
1.
Sure. We don't know though, right? We don't know. We know the total, what we're going to have at the end when we do what with those two. So don't try to solve. So what's your variable? It's not going to be, x is not going to be the total number of goals. X would stand for, really pick either one. No, because that's one. You want x is going to be one variable, y is going to be one variable, and then those together are going to be that. Because that's the total between both teams, right? So what about those two teams? Goal, what do we not know? No, we know the final score. That's the final score. Well, that's the total number of goals. But, oh, sorry, you're right. We don't know the final, but what's the final score made up of? Yes.
How much they?
So it's going to be made up of two teams, but what for the two teams? So their goals, towards their goals. So the goals, so one unknown is the goals for one team. One unknown is the goals for the other team. That's your experience. It doesn't matter which one you make X, Y. You can make X, goals, Y. There are goals where you can put that in either one. I want you to define variables. Yeah, that's one of the equations right there. Boom. So this is the number of goals, right? And this is the number of goals. What's true about those goals? What is true based on one of the rules about the number of goals of one team, the number of goals of another team? Just one. They're all one. Goals are always one in soccer. So I want you to think about what's true about. No, somebody was waiting. Oh wait, actually no. I'm gonna hold you though. I need you to do something. You got a blank paper. She got to go because she had done the equation. Yeah.
Oh, so Mr.
No, the goals for people are weirdly 5.
I know.
I see where you're getting that from, but the unknown is like a variable will never have a number associated with it. It's truly just the one and only unknown. Then the equation will have that number 5. No, wouldn't have, that's still a number. Just the x. The equation will have the 5 in it.
I don't understand.
Oh, yeah, you're not.
Well, did you define the variables?
That's it.
Again, the x will never equal the number, y will never equal the number when you're creating an equation. If we already knew the number, we wouldn't need the equation. Because we know that the reason we're creating an equation is because we don't know the number. Does it say anything about what's the math going on here? Or what's the math between 5 and x? What's 5x mean?
It's how many they combine?
Well, no, that's not math. You're giving me work. What is 5x
Like, let's say there was no word problem. 5x means what? Funny? It's not funny at all to me. So put it in your backpack. Next step is, when that's so funny, your backpack will be up there with me. Next step after that is, not funny. I mean, especially when, I'll bet you if I walk over there, there's not a whole lot on your page, like, or on your page. So what is the math? 5x means what? What is math? Addition, subtraction, division, multiplication, what's math? So does more than, like if we have 5 goals more than, does that seem like it would be multiplication? There you go. I want you to define, nobody's defining variables. I said over and over, Anthony's working on it. There you go, perfect. Now, it wouldn't be how many you won by yet. We're going to take care of that in the equation. It's just me how many goals. Then, so y should be pretty obvious for y. There's no, again, an equation has variables in it. I just said that. If you create an equation, you don't have any variables in it, you did it wrong.
Oh, so
It
this one
needs to
has
have variables in it.
This one has very confused.
Every equation has variables in it. Every equation. That's what an equation is. If we don't need the variables, then we'd just be solving it out and getting a number. Now later we might solve it out and get a number, but I just say create an equation. So you need to have variables. That's right there. That one's not quite right, but we'll talk about it.
Also,
So one of them. Well, but yeah, so plug that in. You know what that is.
no perfect.
Well, it's not the final. X plus y is not the final score. But it would be what? What did you define x as being?
Every turner I
9. Or not 9,
Well,
9.
what's it stand for? It's not a number again. We don't know the
Stop.
number.
X.
Outside that.
Are you focused?
Okay, so what? Be specific. Nels Park what?
He would see you.
So what?
Every time I look at you, my eyes
Goals.
go by the
It's
goals.
the number of goals. So what's y?
Exactly. See this?
The
See this?
clear
You
order
can't see.
goals.
You're,
So what do we know about those?
now I can see.
And that, what I would consider the second rule says what?
Oh, yeah, I drew.
I'm looking at you.
Line
Oh, okay, my eyes.
No, read it literally. What's this? What would you consider the second rule?
Find the 2 rules.
Don't say the spot. Literally, the words exactly what it says in that. Don't make up new words. Use the words in that. The rule is literally one of those sentences.
And you find the amount.
Keep making up words. Read one of those sentences. It's a rule.
You just started it.
No, shut up.
Actually, 2 rules. One of the exact sentences they rule. No, don't worry.
Well, I don't know if you're talking about smartboard or.
Yeah, the smart rule. What else?
Mine.
Oh, sorry.
There you
Mine,
go now.
it says, this is number 2. It says Oh, you're talking about Nels Park?
Talking about.
Oh, are you talking about?
No, I'm talking about the word problem itself. The word problem. Pinellas Park, they throw a actually word problem.
Oh.
One of those sentences is one of the rules. Actually, 2 sentences are really 2 rules. One of them's an easy
Oh,
one.
the total number.
There we go. So what's true about the 2 variables you just gave me?
These were number goals.
Yeah, which is how many?
Sorry, you're about to cry.
So what can you do with that X and that Y and that 9?
I know, right?
Find total number.
Why? Yeah, and that's the what?
Well, to create an
Man,
equation.
this Friday
How
is
do you
so
create an equation
boring.
based on that sentence we just read? The total number of goals is 9. And you just told me that
Marty,
that
I'm
stands
out.
for our goals and that stands for their goals. What do you gotta do to
There'll
make
be
it
so
clear?
much goes there, man.
I'm gonna make Clearwater's goals.
Don't make anybody's goals. You got what you need. We don't know the number of goals. You got what you need right there. What's the total number of goals?
Wanna be your friend?
Nope, don't solve it. Not solve.
Don't solve, don't solve.
Yeah, I mean, you know what'll fix this? Every time somebody tries to solve, smack them. We won't try to solve ever again. You want?
Well, you can
I wish they could still do that.
I don't.
Oh my god. Oh my god.
That would fix it, I guarantee you, that would fix it like that.
Like,
Oh,
yeah.
yeah.
Because you wouldn't try to solve it. I know it, you wouldn't try to
Like, yeah,
solve
already.
it. Hey dude, you know, you got everything you need. What's the total number of goals in the game made up? In that game, what's the total number of goals made up? No, that's the answer. You saw it, solve it again. What's it made up of? How do you get to that 9?
Nine.
Yes, made up of 2 things.
Now it's perfect.
So what's the vanilla spark goal?
5.
No, don't solve.
Don't
What's the
solve.
vanilla spark goal? What's Stan's score?
X.
There you go. X stands for our goals.
And Y stands for
Plus Y equals.
9.
There we go.
I'm,
Oh my god.
I'm not even more, but okay.
Elementary, I was
Now
wondering,
you know.
it was either going to go to Miss Carol.
Yeah, there you go. All you gotta do is get one of these equations at this point. I'm more than fine with that. I'm not doing anything in that right now. You can walk up to me, it'll take me 2 seconds. I don't need to sign anything. You only have one option. You only have one, there's no other option for you to do any other math. So you just circle algebra and that's where you have to go. Everybody in here goes to algebra. No other options.
But don't you need that green paper?
No, I don't.
I thought you said turn it into. Wait, why don't
Oh, if you want to turn it in, if you're on the first collector, then yeah, you can do that. All right, but don't worry, no green papers right now. You can walk out, I'll get them when you walk out the door. We've got to get this down, because we're still struggling with it.
I have it down.
And again, when I yell, I'm not getting on you, I'm just trying to get you thinking.
Can I go to the restroom after this?
Yeah, as soon as I do this one, you can go. We have another one to do though, a couple more. All right, so now let's rein it back in, and I'll calm down. So I need all eyes on me, because way too many of us are not getting this. At this point, I'm really happy if you can just define variables and get one of the 2 equations. If you got both of them, fantastic. And no, I don't think anybody got both of them. But if you did, that would be fantastic. Right now, I think you should be able to get one of them.
Wasn't it 13Y?
I don't know where you get 13. So, here's just stop yelling stuff. So, let's talk about it. When we are defining variables, we have to think, what is the question, or what is it that's unknown? What are we solving for? What are we solving for?
The number of finals.
So it asks us, it says, and sometimes it'll be really obvious. The question will literally just say, what is this and what is this, and that's your 2 variables. This one doesn't do that. This one's a little trickier, but not that bad. It says, what is the final score, right? It says, what is the final score? So we go to the question. So the unknown is what's the final score? Well, we got 2 variables. I can't make both variables the final score. That don't work. That doesn't. I shouldn't use slide. So, broken English, really nice. So, that does not give us 2 different unknowns. But what is a final score made up of? It's made up of the goals that the team score, right? The goals that we score, Pinellas Park, and the goals that Clearwater scores. That's going to be the final score. So what do we not know?
How many did they?
We don't know how many goals we scored, and we don't know how many goals they scored. That's your variables. That's what we don't know. So, and it doesn't matter. I don't tell you anything that will tell you make X this school, make Y that school. So you can make whoever you want X. So I'm going to do X as Pinellas Park. So X is the number for me. If you wanted to do Y as this, you could have. X is the number of Pinellas Park goals. Y is the number of Clearwater goals. That's the unknown. That's your first starting point in every word problem. What is it I'm trying to solve? Sometimes the question might literally say, and I almost did this, but I made it harder on purpose, how many goals did Pinellas Park score? That would have been your X or your Y. How many goals did Clearwater score? That would be your Y. Now, if they only ask for one school, you still would have to realize, okay, well, my other variable just is going to be how many the other schools scored, if they didn't ask for both schools' goals. All right, so we got our variables. There's two rules in here, but one of them I think is super simple. What's one rule that you think is pretty easy? Most of you got this one, I think. A lot of you, maybe not. I don't think. Nope, not the equation yet. I'm going to underline a rule. I underlined the question first because that gave us the variables. Now to create the equation, I'm going to underline a rule. What's a pretty easy rule, do you think? To figure out that, hey, I see that's a rule. I can tell that's a rule that I have to follow.
1 by 5 goals.
I think that one's pretty easy, right? I don't know what the final score was. I don't know how many Pinellas Park scored. I don't know how many Clearwater scored. But I know that the total number of goals was 9. Tells me that right there. That is a rule. Don't know how many each team scored individually, but I know their total has got to equal 9. So how do we make an equation out of that? Say it in words. So what's true about the 9 then? What is the total number of goals made up of?
9.
No, not what is, I didn't ask you how many of them. I said, what is it made up of?
X and Y. X and Y.
Well, before we get to the X and Y,
Oh.
it's made up of, say it again. So it's made up of the number of goals Pinellas Park scored. Well, what represents the number of goals Pinellas Park scored?
X.
So we literally, if we can say it in words, assuming we do this correctly, the number of goals Pinellas Park scored, so that's Pinellas Park goals, plus, there's your math, plus, then the number of goals Clearwater scored, which is our other variable. So again, Clearwater goals. And then here's the key word again. What do we say after that? The number of goals, well, true. In this case, we would literally say equals, but a lot of times you're going to say is. Is stands for equals. Remember that. I'm going to give you a list of those on the next screen.
No.
And then we know it is 9, right? They just tell us the number there. So that's what I consider to be an equation you should be able to figure out. The other equation's a little trickier, especially for the first day. But you should be able to figure out what the variables stand for in this, and then that those two things added together. And again, the reason that it's just X plus Y is because every goal is just worth 1. Or really, it just says here the number of goals. It doesn't even tell you how many points. It says the number, because there aren't points, it's just goals in soccer. If it was football and you had field goals and touchdowns, that's when you'd have to use a 7 and a 3 to figure out the points. Although you could still say the number of scores, like how many times they actually scored, would be the variables. All right, so what is our other rule then? Here's the trickiest part of this one. What's our other rule before we try to do an equation? Just what's the rule? We won by 5, right? So now we got to try to figure out how do we say that in words and then translate that. So, yeah, but we got to use the terminology we have. Basically, we got to use terminology that matches our variables, really. So how would we put that into terminology that matches our variables? Well, but don't get to the variables yet. Use the words behind the equal sign. So that's the number of Pinellas Park goals. So what about the number of Pinellas Park goals? So let's write that. The number of Pinellas Park goals. So actually, let me do it in red since we're doing a new equation. So it's the number of P Park goals. So what, using this rule, that's our other rule we said. So the number of P Park goals, what?
5.
So what does that mean though? What does that mean if we won by 5?
More goals than,
All right, so listen to this again. If we won by 5, do we have less goals or more goals than them?
More.
So our number's higher. How much higher is it than theirs?
Like 1.
1.
5.
1.
5.
5. We won by 5. So our number of goals is higher than theirs, and it's 5 higher.
So our number of goals, say it again, our number of goals,
500.
what? Say that one word.
5.
Nope, before that.
High
Goal.
Is. Our goals, the number of P-part goals is. Is means equals. It's a tiny word, but it is extremely important in word problems. The number of P-part goals is, I'm going to change it to is now. Then we'll do all of that stuff below. Is what? How did we say? We have what? Relative to their goals, we have what?
5 more.
5 more. What do you think more means then?
Plus.
More than that.
But what math? It is greater than. What math is that? Is it times? No, not times. It's addition. It means if they have 10, we have 15. We added 5. If they have 20, we have 25. It's addition. So it is, and I'm going to write it a little differently than the, well, no, I'm not. Not in this one. Is 5 more than Clearwater. So in words, we're literally saying what the equation is in words. And now all we got to do is just say, all right, well, I know the number of P-part goals is what variable? X, right? Is, I already told you, is most of the time going to be equals. 5 is a 5. More than what stands for the Clearwater goals? There's your equation. If you can kind of figure out, now you do have to make sure you use the terminology that's in your variables. Like you can't say how many we scored or something like that. You need to say whatever you define the variable as, try to use that. Say, okay, well, the number of Pinellas Park goals, and then read the rule. Well, it's got is 5 more than plus. One quick trick you need to notice. If we would have said 5, okay, let's do it this way. What if I would have said the number of goals Clearwater scored is 5 less than the number of goals Pinellas Park scored? Let's write that. So what's the number of goals Clearwater scored? Represented by? Y, right? The number of goals Clearwater scored. What's the next thing I write? Is, which is what? And then what's the next thing I said? This time we're doing less than. That's what we would come up with, right? That doesn't work. No. When you're doing less than, because think about it, if they score 2 and we score 7, that's going to give me technically a negative number. 5 subtract 7 is going to be a negative number. We can't have a negative number. So if you're dealing with less than, you actually have to flip the order, because the number of goals we score, subtract 5 would give us their goals, right? Because if we have 7, we would say 7 subtract 5 gives us their number of 2. So when it just, this is the rule, it's not 100% of the time in algebra, it will be in my class. Somebody wrote something?
Huh? No, it's like those like silver things in the bill wrap.
Oh. You need me to do something with it? Huh?
I put it on.
Oh, I thought you were asking me a question.
Oh, no.
Oh, so just remember, here's the rule to follow in my class. Frankie, make sure you write this down. Anybody else, make sure you write this down. If you are dealing with like the difference is, or less than, or something like that, where you know subtraction is involved, like you figured out subtraction is involved, you're always going to subtract the, again, just on what I create. What I create, let me emphasize that. You are going to subtract the number from the variable, even if that's not the way you read it, because we would have said 5 less than Pinellas Park, but you have to flip that. Because otherwise you'd still get the number part correct, but you'd get a negative number, and we can't have a negative number of goals. That wouldn't work. So just flip it around, basically.
No.
All right, I want to do one more, and then you'll do one more. Again, all of these that I'm going over, potential test questions. I'm not going to do any questions that I'm not considering for your either your exit ticket or your next big quiz. I think I copied them over to the next page. Yeah, there we go. All right, so let's look at the first one. This will be in the packet if you download the packet. I mean, a lot of them I'm just going to do in class, so even if you don't download it, you'll still have them in your notes. It says find the value of two numbers, their sum is 12 and their difference is 4. What's the unknown? What are we trying to find out? Trying to find out two numbers, right? Doesn't really tell us a whole lot. Like, it's not like there's a story behind this. It's just two numbers. We can literally, in this case, just say, all right, well, I'm just going to say X is the first number. That is not a hashtag. Y is the second number. Now, I could have gotten really specific, or they may get specific and say, let X be the higher number, the bigger number. Then that would make your equation have to be a specific type of equation, because X has to represent the higher number. Here, we don't even care. X might be the higher number, it might be the lower number, it doesn't matter. We can't really make any mistakes in this one when we do the equation. I mean, assuming we set everything else up there. So now let's talk about what it says. What's the first rule? What's got to be true? What's the first rule? Who am I going to call on? Zakira, what's the first rule in the word problem? What's got to be true about those two numbers? First thing that's got to be true. Here? What'd she say? Well, then you tell me what the first rule is. Can you read it? It says find the value of two numbers if their sum is 12 and their difference is 4. What's the first thing that has to be true about those two variables? Well, that's why I read it to you.
The sum is 12.
There. Still has the rule in it. First rule is what? About those two numbers. What's got to be true about them? Well, I'd say that's the second one. What comes before that? What are they telling us before that about the two numbers? Why am I calling somebody?
No, I already said it like 3 times.
Two people. But she can't hear you because you're taking place in this way and that. Read. I'm not leaving you until you read it, so guess.
What's the sum?
What? What about it? So what? So what? Like literally read what's in the word problem. That is your rule. Oh, well, you can't see, you shouldn't be back there. Why am I just finding that out? If you can't see, you need to be up front. So I'm going to move you up front if you truly can't see. So I'll give you one more shot. Can you read that and tell me what it says? Well, I'm finding that out for sure right now, so there's not going to move.
Yeah, I actually am getting mine.
Well, if you don't have those soon, I got to move you. I can't have you back there and you can't see my
I'm
board.
getting mine soon.
All right, so it says the sum. All right, hang on. The sum of the two numbers is 12. That is a rule. I don't know what the two numbers are, but I know what does sum mean, by the way. S-U-M, what does that mean? I don't know, you tell me.
I know, but I don't like it's in my brain, but I can't see it.
Yeah. Me, myself.
Somebody help her. What does sum mean? S-U-M. Yes, there we go. It means addition. You need to know all of the things I'm about to write about these words. Sum is addition in math.
I thought everyone knew that.
Apparently not. I've only got one person answer me. Also, total is gonna wind up being addition too, but I'm not gonna write that. Like the total goals in the last problem, that led to addition. The total money spent, that leads to addition. I'm not gonna write those because that's just too broad and vague. We'll do some other ones though. All right, so now I'm gonna zoom out, back out. Oh, actually, on here. Oh man. I'll let you go no matter what, but and that's 5 minutes. You got 5 minutes left, not 2.
You do?
Yeah, because that's 2 minutes fast. All right, so sum means addition. So we know what's our equation then? Should be able to do this equation no problem.
12 equals x minus 4. Right?
No. What's true about the two numbers when we add them together? They gotta equal 12, right? That's what sum equals, or that's what sum means. This number plus this number has to be 12. That's what that sentence means. So you better be writing this stuff down. I mean, I got a ton of people that aren't getting it, that aren't writing a darn thing down right now. So when I don't know how to do it, I tried my best. I tried my best. Oh, show me your notes on what we did. Oh, I didn't take any notes. Then you didn't try your best. Trying your best doesn't mean when I finally put a quiz in front of you, you stare at a blank page for an hour. That's not trying your best. Trying your best is putting the work in now. That's like playing a game in the NFL or in major leagues or in the NBA. Oh man, I tried my best tonight. Oh, well, how many practices did you make? Oh, I didn't go to practice. How long do you think they last in the NBA if they didn't go to practice? All right, what's the next rule? We said the sum is 12 is one rule. What's the next rule? Not a whole lot in the word problem. It's only so much to choose from.
Difference.
That's a rule. Their difference is 4. So difference is another word you need to know what that means. That's subtraction. Oh, I know what I was going to write. So more than is also addition. More than is addition. So therefore, less than is also subtraction. Greater than, like 3 greater than another number, would also be addition. That's greater than. Again, I'm taping it if you need to go back and look at it. That's greater than. Fine, I'll read.
Why does it doesn't?
I know. It's because when I zoom way in, the pen writes really fat. So greater than is also addition. Less than, is there another? Less than, more than? Less than is really the only one. They kind of use less than for both of those two. More than, less than, greater than, less than.
Half?
Half would be division, actually, which we're not going to even worry about. Quotient is division also. So if we deal with multiplication, though, I will give you some of those. These mean multiplication. If a number is 10 times another number, literally times means multiplication. I think most of you would get that. That's when you use multiplication. Or if you see the word product, the answer to a multiplication problem is the product. So that's also multiplication. So you need to write all those down. When you read word problems that deal with comparing two numbers or more than two numbers, those give you kind of the math you need to plug in. And then is what? What would we do with the word is? Yeah. Is means equals. That's an equal sign. So again, their sum, adding them together, is, literally put an equal sign there, 12. The word problem tells you exactly what to write. Their difference, again, what does difference have to do with? I got to get rid of this. Do you have all the green down?
No.
All right, hurry. Don't see, you weren't even writing. I look up and you're just leaning back. I'm not gonna wait forever. Like, write it down when I write it down. Can't leave it up forever. What is difference? What math is difference? So their difference, meaning we got to subtract them. I'll write it over here, I guess. We got to subtract them. It doesn't matter what order we put these in, but if they would have said let x equal the higher number, then we would have to put x first, because it's got to be the bigger number. It's got to be y subtract, or we're subtracting y from x. They didn't tell us that, so we can put it in any order. And then it says their difference what? Their difference is, their difference is 4. The words problems tell you exactly what math you need to put in the equation. It tells you where the variable goes. It tells you where the equal sign goes. It tells you what number goes in. Now, they obviously get more complex. Like when you're dealing with money, you got to know to multiply the money times the number of the object, whatever it is. But a lot of times, even that is pretty easy because the money about airheads goes with the variable that's about the airheads. The money about honey buns goes with the variable that's about honey buns. So you just put those together. All right, so I want you to now tell me what are the two equations. So that one was actually for this problem up here. Oh, there. Yeah. So that's your two equations there. I want you to do the two equations for number 2. Again, just find the rules. The rules are always pretty simple.